In this video, we are going to discuss positron decay. Positron decay is basically a conversion of a proton into a neutron, and generating in this way, they generate a radiation known as positron. So in a radioactive element, the nuclei of radioactive element consist of protons and neutrons. The amount of proton and neutron may vary. If a radioactive element have more amount of proton, this may cause a destability or instability of the radioactive element nucleus. So in order to make a radioactive element stable, the proton is basically converted into a neutron. And when a proton is converted into a neutron, a radioactive element, which is a parent radioactive element, is then converted into a daughter radioactive element, and it's generate or it's produce a radiation which is basically a positively charged electron known as positron. So basically, these twin positrons are produced when a proton is converted into a neutron inside the nucleus. And during the conversion of proton into a neutron causes the generation of positively charged electron known as positron. So now, let us define positron decay. Basically, this twin positron decay is a process. It is radioactive process in which unstable radioactive atom or parent nuclei split into daughter nuclei generating high energetic charged, positive charged electron known as positron. So, if I conclude, the positron decay is basically a radioactive decay process, and in this process, basically unstable nuclei or unstable parent atom split into a daughter nuclei, and during the splitting, they also generate highly energetic positively charged electron, and these electrons are known as positron, and the process is known as positron decay. So if I write this or schematically or represent it schematically, in positron decay, basically a proton, suppose it's the proton, it basically transfer or it's turned into let me write, change the color, it's turned into neutron. So in simple word, the positron decay basically is produced when and when a proton in a nucleus is converted into a neutron, and when the conversion takes place, highly energetic positively charged particle known as positron is produced by a nucleus. Positron is represented by a Greek word known as beta. In some cases, positron may be written as E plus, whereas E plus 1, sorry, and whereas E plus 1 basically uh, represent a positive charge. Dear student, please note that the positron is antiparticle of electron. Okay, it has a same weight as an electron, but it is basically an anti-electron. The the anti-electron or positron produced during the positron decay are very energetic. They will fly off from the nucleus of an atom, and their energy will be too much high energy. So now, dear student, let us write a chemical reaction for positron decay. So in positron decay, considered we have an element X. Since you know that every atom has atomic number represent number of protons or neutron or electrons, sorry. Number of protons or electrons in an atom. Similarly, every atom has mass number, which is represented by A, and it is basically number of proton plus number of neutrons in an atom. So now in periodic table, every element is represented with number of proton and neutron with atomic number Z, which is written below, and atomic mass A. So now we consider this is an element and it is going through a beta decay. So it is going through a positron decay. So in positron decay, nucleus of an atom basically has more proton, and these proton will be converted into neutron. So proton, suppose this is a proton. In positron decay, this is proton. In positron decay, this proton is basically converted into neutron. The conversion of proton into neutron in nuclear in positron reaction only occur when the amount of when the amount of protons is more than the amount of neutrons in a nucleus. Okay, so now the proton in positron decay turn into neutron. So this means that number of neutron basically increases and number of proton decreases. So you know that atomic number Z is represent number of proton or number of electron. So the atomic of number Z will be decreased into Z minus 1 when it give 1 electron. Let me write one. When it give 1 proton. So atomic number Z will be converted into Z minus 1 in positron decay because one proton is given and it is converted into a neutron. So this means that a new element will be, suppose it is Y, then the atomic number of new element will be Z minus 1. Okay, and now since the proton is converted into a neutron, but total amount of proton plus neutron in a nucleus is same to the atomic weight of a previous atom X. So this means that the new radioactive new daughter nuclei formed will also have a same atomic weight, and then they will release positron, which is represented by beta plus. So in this way, basically, dear student, nuclear reaction basically will take place in positron decay. So now student, please keep in mind these two rules, okay, for positron decay. Number one rule is that in positron decay, the atomic number, the mass number in positron decay do not change. It's remain unchanged. So any element, any radioactive element going through positron decay, the mass number of that element do not change. Whereas the atomic number of any parent element going through positron decay, it's decrease by minus 1. So, sorry, but decrease by minus 1. So when the atomic number of an element decreases by minus 1, or atomic number of parent element, if it decreases by minus 1, it's result into a generation of new or daughter element along with energetic particles or positrons. In case when a proton is basically converted into a neutron. So in positron decay, student, number of protons in an atom, number of proton in an atom are more than the number of neutrons. So now let us apply these two rules for positron decay to solve the problem easily. Consider an element, consider an isotope of carbon C11, C611. Let us do positron decay for carbon 11. In positron decay, mass number or atomic mass remain same. So the new element formed due to positron decay will have mass number 11, whereas the atomic number of new element decreases by 1. So atomic number of new element will be 5. Now we need to use a periodic table to know that what type of daughter element is formed during the positron decay, and this and what is an element having an atomic number 5. So we can easily find that it is a boron having an atomic number 5. So with the boron there will be a positron decay, and we can basically write beta plus here. or in place of beta plus we can also write E plus. So this is positron decay for carbon isotope. Similarly, we can do positron decay for, suppose, for oxygen 15 isotope. And let us apply these two rules. According to first rule, mass number of parent element remain unchanged, so the daughter element will also have a same mass number as the parent element, so the mass number of daughter element will be 15. However, the atomic number of parent element basically change by 1, so the daughter element atomic number will be 7. So now we can check in periodic table what is the element having an atomic number 7. So it is nitrogen, so we can write nitrogen here, and this nitrogen basically then release, with this nitrogen there will be a release of positron radiation like this. So this is positron decay from O15, your oxygen 15 isotope. Similarly, now dear student, let us solve some problem for positron decay. Consider that an element passes through a positron decay, and in this positron decay, we found that an element is converted into daughter nuclei, and daughter nuclei are basically, it is oxygen O18 isotope along with positron, radiation or positron particle. So what is basically is a parent atom, which is basically converted into daughter oxygen. Since you know that in positron decay, the mass number remain unchanged. So the mass number of parent nuclei or parent atom, sorry, it will be 18. And whereas the atomic number Z, it is decreased by -1 for daughter nuclei. So this means that an parent atom will have an atomic number 9. So now we need to check a periodic table that what is an element having an atomic number 9. So we can easily find that it is a fluorine having an atomic number 9. So this means that a parent fluorine atom is basically converted into a daughter oxygen isotope, and it's released positron radiation. So now consider another question in which we have daughter nuclei which are produced due to a positron decay. It is argon, and the isotope of argon has an atomic weight of 18, atomic number 38, and atomic number is 18, and it's released a positron particle like this. So we need to check that what was a parent element which is basically caused or which produced argon daughter atom and as well as a positron radiation. So basically, dear student, as you know that mass number in positron decay remain unchanged, so the parent atomic mass number for parent atom will be 38. However, the atomic number for daughter element changed by -1. So this means that parent element have its atomic number 1 more. And so the atomic number of parent atom will be 19. So now again we need to check a periodic table that what is an element having an atomic number 19. So we can easily find that it is a potassium having an atomic number 19. So in this way, positron decay basically occur in potassium, and it is converted into argon daughter nuclei, and as well as it's produced positron radiations. So now, dear student, let us conclude beta decay. Beta decay is basically, let us conclude a positron decay. The student, positron decay is basically, it is a type of beta decay in which a proton, in which a radioactive element having a more amount of proton than neutron, the proton is converted or transferred into a neutron, and due to a transformation of proton into a neutron in a parent element, basically result into a generation of a new daughter atom or nuclei, and in this way they release high energetic positively charged electron known as uh, positron, and the process in which proton is converted into a neutron and then its released positron is known as positron decay. So this is all about this trend about positron decay. So thank you for watching this lecture.